Hello Algebra, welcome to the second day of our polynomials unit, and today we're going to be probably doing the easiest part of the whole unit, which is adding and subtracting polynomials. It's not going to be too long of a video, I don't think, because a lot of this stuff is going to be pretty easy to you. Your learning target is I can add and subtract polynomials of any size. And what we're going to realize is a polynomial is, unlike a monomial, it has many terms. So the prefix poly means many. And just like monomial meant one term, polynomial means many. Or many terms. So you'll see an example in just a minute. But really, it's just going to be about combining like terms. And we've done that before. Subtracting is a little different. So with adding, there's really, this used to say distribute a positive one, but we all know that when you distribute a positive one, nothing happens. So I took it off the list. I didn't want to confuse you like there was an extra step. But really, when you add, it's just combining like terms. And you'll see that in just a moment. But with subtracting, that's the part that usually gets people wrong answers because they don't think of it as distributing a negative one, and you really should. And I'm pretty sure that your last year teachers maybe even talked to you about this. And then you combine like terms just like an adding problem. So it kind of makes it into an adding problem. So let's look at our first example. You'll see them like this a lot. So this is a 3-term polynomial added to another 3-term polynomial. And you can do this a couple different ways. You could just kind of ignore the parentheses because when you have a plus sign, it doesn't change anything inside of these parentheses to the right of it. So you can just circle the things that are alike, like this 2x squared and negative 5x squared. And when you combine a 2 and a negative 5, you get negative 3x squared. And then you can combine, let me use different colors and shapes. Oh my, that's not a marker. Alright, let's try that again. I'm going to box in the negative 8x. I'm going to box in the negative 3x. So they're both negative. That means I'm going to add and keep the sign. Get negative 11x. And then last are the constants. I have a 5 and a negative 4. And when you add that, you get positive 1. And that's it. You can't combine any more. They all have different variables or no variables. X squared is not the same as x, which is not the same as having no variable. So that's it. That's my answer. So adding is very easy. So I'm going to show you some subtraction now. So you have this example. It is a 4-term polynomial minus a 3-term polynomial. So in that first step on that first slide, it said distribute a negative 1. So that 1 is invisible, and it's right here. So if you think of this as negative 1 times the rest of this, and we distribute 3 times, we're going to rewrite it. And I like to rewrite it right underneath the first one. And while I'm doing that, I line up like terms. And it just makes it a much more pleasant experience than rewriting the whole thing. So negative 1 times 2x squared is just negative 2x squared. So that goes under the other x squared. So notice all the signs just change. So negative 1 times negative 4x is just positive 4x. And that negative turned to a positive. And the same thing happens at the end. This negative 6 will turn to a positive 6 when you multiply it by negative 1. Alright, now I just kind of have a more traditional looking adding problem. And each column is its own question, really. Negative 3 plus 6, going on to the right side first. So I'm looking at this. Negative 3 plus 6 would be 3. It's a positive 3, so I put plus 3. 6 and 4, that's 10. Again, it's positive, so I put a plus there. Both the 5 and the 2 are negative, so it's going to be negative 7x squared. So that works now as a minus. I'll say x to the third, which just comes down, minus 7x squared plus 10x plus 3. And there's my answer. Here's another great one to practice. I know I skipped. Now we went to number 5 on these old notes that I have. And this time we don't have to imagine a number there. There's already a number there. It's a -2. So that's what I'm distributing. And again, I'm going to rewrite it underneath. If something funny happens, we have -2x to the third. That definitely goes there. And then when I distribute this -2 to the 12, I get -24. You do not want to put it right here, because they are not like terms. So asking yourself, where do I put it then? Well, I kind of just make a new column for it. So you can either make it right here, or you can put out front. But I like it right there because that's where I want it. If I'm going to write it in standard form where the highest exponent comes first, and then it gradually get lower. So 3x cubed minus 2x cubed is 1x cubed, or just plain x cubed. This just brings down. And then the -24 is by itself too. So that's what happens when things don't line up. You just make your own column for them. All right, here's a more involved problem that uses a little bit of geometry. It says, what is the length of the missing side of the quadrilateral shown if the perimeter is 5x squared plus 2x plus 1? So they're telling you with the whole perimeter, if you added up everything, this is what it would be, including with the mystery one. So what we want to do is take away this side and this side, this side, so that what we're left with is just the mystery side. So it really is, if I'm setting this up, 5x squared plus 2x plus 1, that's my first polynomial, and I'm subtracting the sum of all the other things. So I want to do that off to the side. I want to do the sum of the three sides we know. And the easiest way to do that is to just write them in a column. Right, I'm going to put my longest one first, and then 3x squared minus 5x. Notice, and now I've established a column for the x squareds, one for the x's, and one for the constants. And then 4x squared. So those are my three terms. And then you just go through and add. This one just comes down, -1. This is a 1 minus 5, which is -4x. And all these are positive. You get 7, 8, 9. So that's what I'm subtracting. I'm subtracting those three added together. Now I can do my distributing. Let me change colors. And I have a -9x squared under the 5x squared, plus 4x, and plus 1. So I get -4x squared plus 6x plus 2. And there you go. There's your final answer. We're going to do one last problem here, and you'll often find them written like this too, just to try to trick you one more way. It says find the polynomial when x squared minus 2x plus 5 is subtracted from, and that's a key word, 3x squared plus x plus 1. So it says subtracted from. That word from tells you where to start. So we're starting with this one. A lot of times people just write the first thing they see minus the second thing they see, and they don't really pay attention to the wording. So we're going to rewrite this so that we don't get confused. So it should look like that. And then you just go about your problem like you would normally. But I'm going to leave this one up to you. This is the only thing that you have to do on your own, and it's the one thing that I'll check when you come in. This has got to be one of the shorter videos that I've ever done. And we'll have a fairly easy work day when you come in. All right. Have a nice night. We'll see you